So today we're going to look at quartiles and the different things that arise from quartiles. It gives us a more detailed description of the spread. And basically we're going to divide the data set into smaller and smaller parts. Range is good, but it only tells us the highest minus the lowest. We really want more information than that. You may have heard of percentiles. Obviously your percentages is when you divide the data into 100 parts. Well, to score in the 90th percentile, it means that 90% of the scores were less than or equal to your score. In other words, you're in the top 10%. A decile would divide it into 10 parts. A quartile, which is what we're going to look at, divides the data into 4 parts. So the first quartile, Q1, also known as the lower quartile, it's another name for the 25th percentile. So the first quartile divides the data, and the data needs to be in order from lowest to highest, such that 25% of the scores are at or below that value. The second quartile, Q2, that's another name for the median. Third quartile, Q3, would then get the next 25%. It's known as the upper quartile. And so you could think of it as the 75th percentile. So the third quartile tells us that 75% of the scores are at or below that value. That brings us to this idea of not range, but interquartile range. And so it's telling us what the middle 50% of the data, where it sits. So you have your lowest score, it goes up to Q1, there's your first quartile, 25% of the data. That goes up to the median, Q2, and then Q3, there's your middle 50% of the data. That's your interquartile range, Q3 minus Q1. And then of course you go up to the highest score, and there's your last quartile. So to work out your interquartile range, it'll be Q3 minus Q1. So how do you calculate interquartile range? Now, just like when we were working out median, it really depends on whether there's an odd number or an even number of scores. So let's use this example with an odd number of scores, and we put them in order. They have to be in order. So 1, 2, 2, 3, 5, 7, 8, 9, 10. In this case, because there's an odd number, we forget about the median, omit it. So I've just circled it there. There's my Q2. Q1 then is the median of the left-hand side. Now on the left-hand side, I have an even number, so it'll be the average of the two middle numbers there. So Q1 would be 2. On the right-hand side, I do the same thing. So the two middle numbers, average them, 8.5. So my interquartile range, 8.5 minus 2, 6.5. All right, what if there's an even number of scores? How do I work it out? So here's my example for an even number, 6, 7, 8, 9, 9, 10, 10, 11, 13, and 15. Okay, break the data into 2 halves. Because there's an even number of scores, we can do that. Both of my halves have 5 pieces of data in them. Q1 will be the median of the left-hand side. We just work that out using our same rules. Odd number, like I've got here, it'll be the middle number. So Q1 is 8. If it was an even number, find the average of the two middle numbers. Q3 would be the median of the right-hand side. So 11. In quartile range, 11 minus 8 is 3. Q2, our median, remember, is the average of the two middle numbers, so 9.5. That rule doesn't change. This brings up a thing called a 5-number summary. The 5-number summary of data is when we write down the minimum, Q1, the median, Q3, and the maximum. So basically it's the quartiles, but we also include the minimum and the maximum score. That's our 5-number summary. So our 2 different examples there would have 5-number summaries. Well, the first one was 1, 2, 5, 8.5, and 10. And our second one there, 6, 8, 9.5, 11, and 15. Now, box and whisker plots. How can we graph this information? Well, that 5-number summary, that's what we're going to graph. It's really useful comparing different sets of data and when you draw parallel box plots. So let's say we've got a class that's sat a major exam, and there's 2 different classes, class 1 and class 2. Here are their results, and I've placed them in ascending order to make life a bit easier. We're going to put them into parallel box plots. All right, I've done the calculations already, so here are the graphs. So the red one there, class 1, is for the top data, and the blue one is for the bottom data. Now, looking at the red one so you can see how I created the box plot, the actual box in the middle is the interquartile range. So it goes from Q1 to Q3, and we place a line at the median, Q2. The whiskers then go out to the lowest and the highest scores. And then we've done the same there for class 2 as well. All right, so what we can tell from here with these two classes, for instance, now we have a visual representation, but we can see that, well, almost the whole of class 1 fits into the top 3 quartiles there of class 2. But what about outliers? Outliers can really affect your data. So it's something unusual. So that class 2 that we just saw, it might be, look, we've got 2 pieces of data there, 23 and 37. Other than that, it would have started at 60. So these 2 scores here are having a big effect on that tail. So if you've got data that's an abnormal distance from the rest of the data, so how do you identify one? Well, here's a common way of doing it. It's basically 1.5 times the interquartile range. If it's further than that distance away from Q1 or Q3, we say it's an outlier. So you've got to pay close attention to that. If you're using this information and presenting it to someone, you need to let them know that there were outliers there and you've decided to include them or exclude them depending on what you've done there, because it is going to affect your results. If you do exclude them, as I say, the existence of those outliers should be acknowledged. So let's have a look at that data again and have a look at class 2. If I include the outliers, we get the original box and whisker plot. But if I take them out, so those 2 dots there are the outliers. I've still put them in my graph. I just haven't put them in my box and whisker plot. But now you can see that the data sets between class 1 and class 2 are a lot more close together. The average of the first data set was 82.1 and the deviation 9.37. Now with the outliers, you can see there's a significant difference in the average there, 72.1. And the spread's quite large. But take out the outliers, that average becomes, well, becomes closer to the mean, and the deviation, so the spread has come in as well. So 15C, we'll have a look at that.